Welcome to design of transmission system. We are going to solve one problem on design of flat belt drive using fundamental equations. Determine the width of the belt 9.75 mm thick leather belt required to transmit 15 kW from a motor running at a 900 rpm. The diameter of a driving pulley is 300 millimeter. The driven pulley is run at 300 rpm. The distance between the center of the pulley is 3 meter. The density of leather is 1000 kg per meter cube. The maximum allowable stress in leather is 2.5 megapascal and coefficient of friction is 0.3. Now, after reading this problem, we are going to analyze what are the parameters given. Now we are going to write one by one the numerical data, underline the data we have to write. First one, thickness of the belt D is 9.75 mm, that is 9.75 into 10 power minus 3 meter. Power transmitted B is 15 kilowatt. Speed of the driving pulley N1 is 900 rpm. Diameter of driving pulley is 300 millimeter. Speed of driven pulley N2 is 300 rpm. Then the center distance C is given as 3 meter, that is 3 into 10 power 3 millimeter. Density of belt rho is given as 1000 kg per meter cube. Allowable stress sigma is given as 2.5 megapascal. We convert into Newton per meter square, so multiply by 10 power 6. Coefficient of friction is given as 0.3. Here we need to find out the width of the belt, for which the step number 1 is first calculate the diameter of driven pulley. We know the formula I equal to d by d, which is also equal to n1 by n2. Using this relationship, capital D diameter of driven pulley is calculated. Substituting value we get as 900 millimeter. Second step, we need to calculate the linear velocity. We know that V equal to pi d n by 60 into 1000. Substituting the values we get 14.137 meter per second. Step 3, angle of contact theta. We know that theta for open belt drive is 180 minus d by c into 60 degree. Substitute the value we get 168.52. So multiply into 5 by 180 for getting the radian, so we get 2.9413 radian. Step 4, calculating ratio of tension. We know that for flat belt drive, T1 by T2 equal to e power mu theta, e power 0.3 into 2.9413, we get 2.4167. Therefore, D1 is equal to 2.4167 times of T2. Step number 5, power transmitted. We know that power P is T1 minus T2 into V. Therefore, T1 minus T2 is B by V. Substitute the value, we can get this relationship equation number 2. Now, we want to calculate the tension values T1 and T2 by solving the equation 1 and 2. We get this equation 2.4167 times of T2 minus T2 is equal to 161.05. Therefore, we can get the value T2 as 748.96, T1 as 1810.01 Newton. Step number 7, calculate the centrifugal tension. We know the formula Tc equal to mv squared, where m is mass of the belt. By calculating the values rho into b into d. Rho is density, b is width, d is thickness. Here width of the belt we don't know, we substitute in terms of b. So we get the mass in terms of 9.75 b. So m into v square. We get the Tc value in terms of width only, right? Last step, we need to calculate the maximum tension. Equating the maximum tension, we have the two formula. One is T1 plus Tc, another formula is sigma into B into D. We equating this, we will get the value D1 you substitute 1810.01, Tc as 1948.58 times of B. and sigma is 2.5 in 10 power 6 with B thickness is 9.75 in 10 power minus 3. You solve this value, we can get width of the pelt B as 0.0807 meter. We need to convert into millimeter, so we get the answer as 80.70 millimeter. Thanks for watching this video. Thank you.